All right, everyone, we'll be getting started. Please find your seats. That means you, John Van Oppen. All right, please welcome John Spring with CERT. Thank you, John.
Hi, everyone. So this is a discussion of some stuff that I was doing to try to detect some malicious behavior on the internet. It actually goes back for some time. This will be a bit of a survey just to get the flavor of what's going on. If you want to look at the technical details, we actually just published this as a tech report last Friday. Seems like a long time ago to me for some reason. I'm coming in from Pittsburgh because we're out of Carnegie Mellon University. Unfortunately, I cannot report that the Pirates are going to the next round of the playoffs. Hopefully I'll report that tomorrow. So, first step, of course, is the useless legal language. Now that you guys have all consented to monitoring of everything that I'm doing, I'm going to move on. All it really says is that I don't promise that any of this is real. So, fast flux is not new. I'm going to be talking about name servers doing fast flux. I'm going to put fast in air quotes. But fast flux is not new at all. ICANN reported on this a long time ago. And if ICANN is doing a report like this, then it has percolated up pretty far into the DNS awareness. So, in case you didn't read this paper in 2008 or have forgotten it since then, because we're all getting old, basically, fast flux is if one domain uses a bunch of different IP addresses. The botnet authors do this to avoid IP blacklists, basically. So if they hard code the domain name or something into their malicious code, then they can cycle through the IP addresses, which gets around the block lists. They soon realized that this wasn't enough, so they started also cycling through the domain names. And so you have multiple domain names which are hosted on a related set of IP addresses. But the time to live for these is, 5 seconds, 5 minutes, something rather short. So you might say, didn't we take care of this 5 years ago? Why do I care now? We have a pretty good mechanism for taking this stuff down reactively, but pretty good is relative, right? It's always reactive. So if we're reactive and we're taking something down, we're playing whack-a-mole as a defensive community. That's not ideal. If you're playing whack-a-mole, you're going to lose. I actually just 3 weeks ago in San Francisco presented a paper with some modeling about this and why this is definitely true. If you're playing whack-a-mole, you will not catch up, right? Because you have to react. So if they're doing a fast flux botnet and they only need to get one domain name through and one IP address through out of 500,000, and they can update their bot to evade your defensive mechanisms, they will do that. They'll win. Right? We see this with Conficker. Conficker still exists all over the place. So, given that this is a latent problem, click, there we go. What can we do? So, domains need two things. They need a location. As I said, we already have tried blocking the location. We've already tried IP-based block lists. Those work okay as long as they're actually, owning the IP address that they're using for malicious purposes, but that's not often the case. Everyone has compromised machines on their infrastructure somewhere, and you can't just block the IP address if it's been compromised because you take down legitimate services. So, since there are only two things that something needs in the DNS to be active, let's try to look at the name servers. So I did this two ways. I did the same algorithm, but I did it on two different sources, which have slightly different features that I can take advantage of. So certain top-level domains make their zone files available. These are the generic TLDs, com, org, net. So the zone files give me a pretty good insight into the second-level domains on the internet, because com is half of them, right? But that's still not everything. And in general, I only have daily resolution on this. So if some bad guy in the zone files changes the IP address of his name server 4 times in a day, but the last one is the same as the first one, I won't see that it's changed because I can only pull it down at midnight. On the other hand, I have a passive DNS data source. So I have the contents of the resource record sets. So I have the IP addresses of the name servers and the domains that are used as name servers from that. And I can see down lower labels that are name servers. I can also see all the TLDs that get requested, but it's incomplete. So you'll see slightly different results from these two data sets, but it provides a way of looking at both things. That, one gives completeness for everything in a zone, one gives a sample across the whole internet, so it's a little bit more complete. The passive DNS source has a slight North American bias, so there's that. What I do is pretty simple, and it's related to the fast flux detection in general. So you look for things that move IP addresses, and you prioritize those things if they change ASNs pretty frequently. The name server is supposed to be stable, right? You guys that run name servers, you know that your name server should not be changing IP addresses. That's basically forced downtime if your name server changes IP addresses, because there's going to be the TTL timeout and people are going to get confused. Might be reasonable for this to happen once or twice in a month. Probably once, right? People do change their name servers, but they try to not do it so frequently. Even someplace like Akamai, I've gotten several questions like, isn't this a CDN? Isn't this going to change all of the time? That's actually not how those work quite. The resource pages, the end leafs of the CDN are going to change all the time, but everyone needs a stable place to ask for what those very variable resources are. So although Akamai might have 100 or 200 or whatever it is name servers, and they might vary which ones you ask questions to, each individual name server stays in the same place. The IP address doesn't change. So what I'm talking about is the actual name server changing IP addresses. And particularly, I care if they change AS, because if it changes AS, it's changing who's in control of the network. Right? So pretty reasonable if someone's changing their name server from one IP address they own to another one. But if you're on, the customer net block for a ISP in France, and then the name server changes to the customer net block for an ISP in San Francisco, I'm pretty sure that that's not real. So I know that you're all surprised that bad things happen on the internet. Please force laughter a little bit. Okay, thanks. There you go. If you look at this, you have the number of changes in IP address and the number of changes in ASN. If you look at, say, row 4 or 5, there are actually more in the right-hand column, AS column, than there are in IP column. This is because if something changes IP address 9 times, it might only change AS 5. So it's not out of the 198 that changed IP 4 times, how many changed AS. It's how many changed AS 4 times out of all of them. So I would venture a guess that 0.2 or 0.1% of the things in the zone files were malicious for as far as name servers go, if you sum up down there. In the passive files, there were a bit more. This is because the time granularity is better, I think. It also might be because the generic TLDs have a bit better security on the people that they allow to register names. I think that's a pretty reasonable guess as to why this is true also. Not sure exactly which one of those it is. But as you can see, there's a bit more suspicious looking name servers if we look at passive DNS. So that data was from 2011. If you look at this, this is the number of name servers that changed IP address 5 or more times within the 30 days prior to the date on the bottom. This runs from October 1st, 2011 until 2 weeks ago. That big spike is when DNS Changer was taken down. So they were doing this to keep their name servers up, that they were serving all these malicious ads that was stealing all of this money. Also, if you note, they looked like they were serving names that had suspicious strings in it, right? There's usually not too many name servers that are RX free pharma Viagra Cialis.nameserver.net or whatever it is. So that's what that red line means. They had one of those kind of words in it. Very simple. I'm not actually analyzing like where they sold anything to. I'm looking at the strings in the name server name. However, that peaks out at 3,500 name servers doing this in the zone files. It drops a lot, so we can certainly affect it if we go arrest 6 people in Estonia and turn off their servers. So that's good news, but maybe we can do it without quite so much effort by the FBI, right? Maybe if we look at this from a technical point of view, we can also do something. That number stays pretty stable between 400 and 600 name servers doing IP flux in the zone files for the big generic top-level domains for the last 2 years, 22 months. So I do say that this can be changed because obviously it can be affected, but I also say that this is still somewhat of a problem. You do not know how many domains those 500 name servers are serving, right? We could find that out, but that's just not what I did on this graph. So just because 500 name servers can probably control a good amount of malicious infrastructure. Also, I said that I'd adjust the parameters. The parameters for name server IP flux are not the same as that for regular IP flux. This is why no one else found it. Right? You don't find this by accident when you just regularly run IP flux calculations. It hides all of that because, in general, name servers are more stable. This is all name server IP address TTLs. So if the domain was a name server, this is in the passive DNS what the TTL was for its A record. 41% of them were 2 days. Almost all of them are either 1 hour, 1 day, or 2 days. What does this tell you besides that this is a log-log plot and that I might know a little bit about how logarithms work and that maybe I'm therefore intelligent and should be listened to, which is probably not what we should take away from this graph? That name server records behave differently than regular records, so we have to look at them differently. We have to look at them especially. Also, if you look, almost all name server records have a TTL of more than 5 minutes. So with regular fast flux, one of the defenses was you can pin names for 5 seconds in your name server, things like that. You actually don't accept new things. You pin the resource record for 5 seconds. With name servers, this is a pretty big study. I looked at 760 million records. You can probably pin name servers at a lot longer, depending on exactly what percentage of people you want to frustrate. If you pinned it at 5 minutes, you would frustrate probably 0.02% of name server records. That's less than the ones that I claim are malicious, so you probably shouldn't care what they say anyway. You can pin it a bit higher if you're a bit more ambitious. When someone gives a security talk, you should always ask, so what? Right? I'm not here to sell you anything, so I'm not claiming that the sky is falling and that you should buy something from me. So there's no analytic reason why people should change these name servers so much. If they change this much, they're probably doing it because they're running from somebody. So if you care about protecting someone from it, and that might actually just be your corporate 10 people that actually run your network. I know that you guys are running networks for big customer bases that you can't just dictate what name servers they go to. If you run a DNS server for your own employees, though, you probably want to care about this. If you run a bigger name server, you might want to think about caring about it, but there's also all those contracts things. I do claim that it's a high confidence indicator, and that more importantly, transitioning to blocking name servers is more effective than trying to play whack-a-mole and catch up on just blocking the actual domains after we see that they're bad. If you block a name server, it blocks all the things that are resolving using it. So you jump out ahead a little bit and you help to win this asymmetric battle that's going on where the attackers have this asymmetric advantage if they only have to get one thing through. I am curious if anyone has looked at this on securing their networks. I don't know of anyone that has, so I would like to know if someone has. You can come talk to me later. I would especially like to know if you tried this and it did not work. So I could try and spend a lot of effort proving to you beyond a reasonable doubt that this is bad. I have some good reasons to believe that that's not fruitful. I could try to sample some of these name servers and run them down, but I think that that's more or less done with that 3,000 of these went offline when DNS changer was taken down and those servers were taken off. I also have done some other work looking at blacklists and intersections between them, which makes me question the utility of just intersecting some list of names that had come up with someone else's blacklist and saying if they agree, then I'm right. Because everyone looks at different things, and so almost no blacklists actually intersect. So it would be hard to pick which one, and I would just get to pick whichever one made me look the smartest. which is not the best way to try to actually get the right answer at something. I do continue to keep track of this, and I intend on doing that for the near future and the foreseeable future. I am bringing this to some attention because it might be the case that some registries are in a position to pay attention to this, and if not actually do anything, feed it into some other abuse process, right, to keep track of something. In the meantime, if you keep track of the DNS queries that you ask for your organization, you can do this yourself. That tech report has all of the information about what you would need to do to actually look at this. It's pretty simple though. You can block this, I would suggest, in a DNS, in the actual DNS server like RPZ, because you want to actually block requests to the name server. The point is that those are changing IP addresses, so just blocking outbound 53 to that IP address might not be effective once it changes name server. If you link your firewall rules really carefully with your name server, then you can probably do it that way. That is all I have. I have about 14 minutes for questions, so I hope that there's at least one, and then I can continue to talk.
Good morning, Matt Petak from Yahoo here. So you've identified 400 to 600 name servers that you think are suspect or potentially troublemakers. Do you have this compiled and listed anywhere that we can make use of, or are you going to ask each of us to go ferret out the name servers for ourselves?
I can make it available, but I do have to, I can't just publish that based on CERT's rules.
Disclaimer slide up. Isn't that good enough?
I would like to say that that was true, right? I can give it to you, certainly. Publishing it publicly is a little bit more difficult. However, I would be interested in exploring where we sort of hand it off to someone else who might incorporate it in something that they would use that might have better dissemination.
I would be very interested in getting a copy, even privately, if that would be possible.
Yeah, come talk to me afterwards.
Get kind of virtualized. I was wondering, did you talk with any of the folks at ICANN, particularly during the RIA discussions about potentially putting in clauses that implement sort of name server, frequency name server change?
So I thought about that, and I basically, CERT decided that it was not our, we were not going to issue a response to any of those RAs. So I'm doing the best I can, given that I know that I'm past that period. Right, but that would have been ideal, however.
Andrew Sullivan, I work for Time. The remarkable registries is, sort of fun, but given that we're about to expand the number of them anyway, it doesn't seem like it would do everything you want. And in any case, it's sort of trivial for these people, right, to just move them a layer down. There's nothing special about the TLD registries that give them the control of this stuff, especially for NSSet records. So I don't actually think that rule is going to get you anything.
So this is always a matter of, how much effort do we put in on what areas. I agree that it's not any kind of silver bullet. There is no one silver bullet. If you can, however, clean up certain TLDs better, right? You have better assurances that things in precisely that second level are safer. And if I get to the point where I can just say, I'm going to block all dynamic DNS on my secure network, right? Because everything bad has been forced out of all of the traditional registries because they keep track of it, that is not trivial. That's not useless.
This is Andrew again. I really want to press on this then. First of all, as a matter of fact, ICANN just doesn't have that capability because all of the CCTLDs are not subject to ICANN regulation. There's no contract there. So you simply can't do it. Essentially what you're trying to do is tell the sovereign government they can't do something. But also because of the large expansion of the root, I think that this is a whack-a-mole problem that just expands forever. And I can't seriously believe that manually compiled lists of this sort are really the thing that we need to do. It seems to me rather what you need is something that was implied by one of the previous commenters, and that is we need a reputation list for this sort of stuff. That's to the extent that it worked at all in the mail world, reputation lists are what work the best. And so it seems to me that if we've got this kind of problem and you want to do something about fast flux or any kind of flux, you've got to do something based on reputation lists.
Oh yeah, and I did not actually say in the slides ICANN at all, because I'm aware of they don't actually, to the extent that they have contracts with the CCTLDs, they are not so binding on behavioral modifications. So each TLD is going to have to be convinced of the utility of this independently, which does not exactly give a nice, friendly, single point of contact to make any changes. But that doesn't mean that we just throw up our hands completely and say that, oh, this is hard, we better not try at all.
I'm going to pitch a question from the table up here. We've heard in recent talks in other conferences that there are millions of open recursive DNS resolvers on the internet. Is that something that's crossed CERT's radars? Do you see any overlap with the issue you're talking about here? And it was like 32 million open resolvers out there.
Yeah, so the number of open resolvers is large, and yes, I'm aware of that. That's a different sort of issue, I think, because with the open resolvers, one of the things that people are really worried about is the reflection and sort of public health concerns, which I think is a serious issue, but I think is separate from denying the malicious content controllers their ability to actually have some sort of master copy. So, right, you can certainly use an open resolver to make the query around some sort of protection that you put in place, I suppose, because they are a proxy effectively. So to some extent, right, proxies are always a problem, right? The internet is a logical network, not a physical, so we can't, oh, well, this is carved off here. So it does affect, the more things that are wrong, it's a snowball effect, I think.
Any more questions?
Great.
All right. Thank you very much, John.